Okay, just a quick application of these areas to physics. If I'm driving, if I'm driving at 100 kilometers per hour for 2 hours, how far do I go? Well, surprise, surprise, it's 200 kilometers distance covered, 200 kilometers. Okay, what is this? This is some basic physics. But, what do you want to interpret this as in a calculus class? Well, you want to interpret it as an area. You have your speed or velocity, and then you have time. So let's go velocity, time, and I just want to remark that this 200 here, oh, that's a shaky hand, too much coffee. Now, where was I? This 200 here is the area under the velocity curve. So velocity curve is horizontal in this case. And then this area here is the 200 kilometers. Okay, not very fancy, but what if my velocity is a very complicated function? If my velocity function is some complicated function, some function of time, Let's say I'm driving for 2 hours, and I start off at rest, right, usually, and then you maybe quickly accelerate to, say, 80 kilometers, then you hold that for a while, then you slowly accelerate, and whatever. Oh, maybe you slow down, and maybe you start cruising again, whatever. It's going to be a lot more complicated in real life. But the point is if I want to find the total distance covered, how am I going to do that? Well, this is where my idea of area comes in again. Use lim Rn to find this area. Which is the distance traveled. Okay, so you can see how this could be useful. Okay, these areas in, a more complicated physics situation.